key points about the voids. So here it is. If you go through the structure of the cubic unit cell, you will come to know that the cubic diagonal is root 3a. If edge length is a, if the cubic lattice is made up of the edge length a, then the cubic diagonal will be root 3a, right? So at root 3a means at the cubic diagonal, two tetrahedral voids are present and one octahedral voids are present. So let us calculate where the tetrahedral voids lies and octahedral void lies, and what is the distance between the tetrahedral voids and the octahedral and tetrahedral voids, right? So here it is. So if A is the edge length of cubic lattice, cubic cell, right? Then the cubic diagonal is equal to root 3a. Now at cubic diagonal, two tetrahedral voids and one octahedral void is present, right? So let us make here a cubic diagonal. That this is root 3a, right? And here the half of this is root 3a by 2 and 1/4 is root 3a by 4. So two tetrahedral voids and one octahedral void. Octahedral void at the center of the cubic diagonal. So at the center, one octahedral void is there, and this is, here is the, this is root 3a by 2, and this is also root 3a by 2, right? And in between the corner and the octahedral void, there is a tetrahedral void in between. So in between, here is a tetrahedral void, and here it is tetrahedral void present, right? So this distance will be root 3a by 4. This distance will be root 3a by 4. This root 3 by 4, and this also the root 3 by 4. So here from this we may calculate the nearest distance between the octahedral and tetrahedral and between the two tetrahedral voids. So let us write here the distance, the nearest distance between tetrahedral voids is equal to, so two tetrahedral voids, one tetrahedral here and one tetrahedral here. So root 3a by 4 plus root 3a by 4, that is root 3a by 2. So it is root 3a by 2. Now the next is the nearest distance between tetrahedral void and octahedral void. It is root 3a by 4. So the nearest distance between octahedral void and tetrahedral void is equal to root 3a by 4. So now the next, And the most important thing, it is if crystal has n number of particles, then tetrahedral voids is equal to 2n and octahedral void is equal to n. On the basis of this, the question comes. So let us have some questions on the basis of these number of tetrahedral void and octahedral voids in the crystal lattice. So now here is the question about the voids. This is type A atoms form FCC structure. B occupy 2/3 of tetrahedral voids and C occupies octahedral voids. Find the formula of compound. So here, if you are going to see, the FCC structure is given, right? So that means FCC structure. That means number of atoms in FCC is equal to 4 atoms, right? And A atoms form FCC structure. That means the number of atoms of A type particle will be 4. So number of A type particles is equal to 4, right? Now next, B occupies 2/3 of tetrahedral voids. So number of tetrahedral void, number of tetrahedral void is equal to 2n, 2 multiply number of particles in the number of particles in FCC, 2 number of particles in FCC, that is equal to 2 multiply 4, that is 8, right? So here number of B type particles, B atoms is equal to 8 multiply 2/3, so that is 16/3, right? Now next is C occupies octahedral voids. So number of octahedral voids is equal to number of atoms in FCC, that is equal to 4, right? So here the number of that is C type particles, atoms is equal to 4 because it occupies all the octahedral voids. So now the ratio, the molecular formula, the ratio A is to B is to C will be A is 4, B is 16/3 and C is 4. So the fraction, it is in fraction. Atoms cannot be in fraction. Atoms always in complete way. So here I make it in the whole numbers. So here it is equal to 3 is to 4 is to 3 multiplied by suitable integers, right? So A type molecules 3, B type 4 and C type 3. So the molecular formula will be A 3, B 4 and C 3. So this is the molecular formula of the compound. Right? So this is the question. Now the packing efficiency. Packing efficiency is actually the space occupied by the atoms. The more space occupied, the more is the packing efficiency of the crystal or crystal unit cell. So here The packing efficiency, here is the formula of this, that is the packing efficiency is equal to Z, and Z is the number of atoms in crystal unit cell, right? For BCC it is 2, for FCC it is 4, and for cubic unit cell it is 1. So here it is multiply volume of one atom upon volume of unit cell, right? So this is the formula to calculate the packing efficiency. Now one by one we are going to take the unit cell types and calculate the packing efficiency.